Well, hello everyone. This is KP the Math G, and well, this is the last. Those of you who've been watching my videos on a regular basis, you know that I've done quite a few of these, and really with good reason. I just want those who are still struggling with this just a little bit to get this down. If you look at my 75th video, this is going to be my 76th one. If you look at those last two videos, I think you'll get this. Now all I'm going to do here is I'm just going to set these up. I'm not going to solve, okay? And I think if you can get the gist behind it, you will be able to do any of these. Now if you just look at the last video, I had the isovenerables going perpendicular to the x-axis. Okay, this one is going to go perpendicular or to a line that's parallel to the y-axis. Okay, and so we're going to deal with that. We're going to actually do two parts here. I'm going to rotate one region about x equals, -1, and then the other one I'm coming over here somewhere probably to 3, probably up to about 3 or 4. I don't want to go too far out this way. This is my work area, so I really need to limit my space. I wanted to make this big enough where you could see there's not a lot of gap in between these two curves or lines, or line and the curve. And so I just had to make this as big as possible, but I still need work room here. Okay. All right. Well, what are these two regions anyway? Well, one of them is, let me look, do it by heart. I don't know why I'm even looking at my paper. Okay, so one of them is y is equal to x squared plus 1, and then the other one is y is equal to 2x plus 1. Alright, now if I'm going to rotate this region right here, okay, this region inside here about this line right here, I know they're not, I ran out of space here, so I just made it, this is really a little bit off, so I mean, you know, I wish I had a grid board, then I could make everything a lot more accurately than what I have. This is definitely not parallel, but we're going to pretend that it is parallel. Okay, well anyway, let's get started. Let me get a color here, and I want to draw my isovenable. Now I want to start from x equals -1, right about here. It doesn't matter, let's go right here. Alright, right there, that's it. Alright, my isovenable going right through there like that. Okay, now this right here, this thickness is not delta x, but it is delta y. Alright, because we're working on a line that is parallel to the y-axis. Okay, alright, and keep in mind that we need to figure out the points of intersection. Okay, we already see real quickly this is 0, 1. I'd rather just go ahead and show you what they are. I will show you how to go about doing this to find it. And this one here, by the way, is 2, 5. Okay, so 2, 5. And I deliberately made this a little bit wider so this graph could be more visible to you. Okay, That's kind of what I wanted to do. Let me adjust my light here. I don't want it to glare on the board. Okay. Alright, now let's determine now how long. We've got to remember this is a washer method. Okay, a washer method because this area here is solid and the rest of this is not. That's a hole right there. Okay, if you can imagine that being revolved back behind the board somewhere, you're going to leave a hole. This area right in here, this region in here, is a hole. Alright, this region here is solid. Right there. So when you're talking about and integrating from A to B, it's pi from A to B. Alright, big R squared minus little r squared, and in this case we're dealing with dy. Okay, you see that? It's always going to be this pattern if you have a hole, an empty space between there. Okay? Alright, now first of all we got to the big R is going to be the hole plus the solid. Alright, well let's see. We also have a distance from here to here too, by the way. We have a distance from here to here. You know that that's, I know that that's drawn so daggone crooked, I'm so sorry. But this distance right here is 1. So what we're going to be doing is we're going to add 1 to this, this whole distance is 1 plus the rest of this right here. Well, let's see, how far is it from the y-axis? How far is it from here to here? Okay, this distance right here from here to here is x, isn't it? We're going along parallel to the x-axis. This is the x distance. Okay, anytime you are looking at this isointerval that is parallel to the x-axis, you're going to say this is x. Well, these are y's. We got to solve for x, don't we? Okay, so when you have your isointerval running parallel to the x-axis, you have to solve for x. If your isointerval is running parallel to the y-axis, then you got to solve for y. Okay, so this is what we're going to do. All right, but first of all, let's just examine this then. This distance is 1. This distance is x. So this distance is, let me erase this other because I need all the room I can get on this. Okay. Let's put it up here. This is pi. Now, we're going to worry about the limits of integration in just a moment. But right now, we're just going to set this up. This distance is 1. This distance is x. Alright? So this is 1 plus x, which we're going to find out in just a moment what x is. Now, this x here, I'm not going any further. I know I've got to minus off something else right here. And I'm going to put dy on the end right here. Well, I'm going to need some more, but anyway, it's 1 plus, and it's squared. Oh, I got to square this one too. Alright. Oh, excuse me. Let's put this, I know I'm going to need more room than this. Okay, now we're going to put something in here a little bit later. Let's concentrate on this part right here. 1 plus x. Where does this x touch right here? Which, this is a curve right here. You would guess that the curve would be the x squared one. The line is in green. Okay. So I want to solve for this x right here. I want to solve for this x and put everything in terms of y right here. So I have y is equal to x squared plus 1. Let me subtract 1 on both sides. Okay, so y minus 1 is x squared. You know, I probably could go ahead and leave it as just y minus 1 because this is squared anyway, right? But I'm going to go ahead and just solve for x. Okay. Well, no, I've got to go ahead and solve for x. I see it now. Now this is usually plus or minus, but since we're on this side, on the plus side of it, we're going to make this plus. Okay. So x is equal to the square root of y minus 1. Now remember, I'm adding 1 to that. So in this case, I'm coming over here. Alright, now this is 1 plus this x right here. We might want to call this x of 1 because there is an x of 2 as well. Okay, the green line would be x of 2, which we'll look at in just a moment. Okay, but right now, alright, so this x of 1 here is this purple line, or this curve rather, alright, which is the square root of y minus 1, and we're going to square that. Remember, this is big R squared. Okay, that's that. Okay, and I'm going to need all the room I can get here. Alright, that's that part. Okay, so this, you got to count this 1, not negative 1. It's how many units you are away. So this whole thing is 1 plus x. 1 plus x of 1, which this x here is the square root of y minus 1. I need to put that up here somewhere. X, let's put this down here. X equals 1, the square root of 1, or y minus 1 rather. Alright, that's in relation to this bottom one right here. Okay, now I need to fill in this portion right here, close it in, and say dy. I need to square it. Oh boy, I need everything, don't I? I need every little inch of this board, I tell you. This is squared dy. Now, let's look at that. Let's erase this, wherever I put my eraser. Okay. I can't flip my board over because I want to see what the graph looks like. Okay. Alright, there's that one. Okay, now let's fill in this part. Now this part here is the hole. I'm just looking at what the hole is, and I'm going to square that. I want to take that away because all I want is just this little bitty, I just want that right there. Okay, alright, so I got to take away the hole. Alright, so let's see. How long is this hole? Well, we know it's 1 unit long. Okay, that's 1. We've already established that from the other problem. And how far is it from here, from the y, to this green line? Which, by the way, is 2x plus 1. Yeah, it's x, but now that was an x a while ago. We need to call this a different x. Maybe we'll call this x of 2. Well, we want to make this x of 2, so let's make it x of 2. We made this x of 1. x of 1 here. This is x of 2. All right, I'm going to solve for that. All right, so y is equal to 2x of 2 plus 1. So minus 1, minus 1. So again, y minus 1 is equal to 2x. And I'm going to divide by 2. So x is equal to y minus 1 over 2. So in the other problem, I'll put it somewhere else. We got to put that here. Now, this is 1 plus x of 2, isn't it? 1 plus x of 2. Alright, so 1 plus, this was x of 1, this is x of 2. So 1 plus x of 2. See the pattern. If this was 1 plus x of 1, you might as well just go ahead, instead of trying to figure all this out, if you see the pattern on the first one, then this is 1 plus also. Alright? If it had been 1 minus, this would be 1 minus, which we're going to find out in just a little bit. Alright, so this x of 2 is y minus 1 over 2 squared, like that, and closed in like that. Now, I could do some arithmetic. I could fix this up a little bit more if I wanted to. But I just wanted to give you the idea. Okay? That's what I'm talking about. You just got to know that it's always going to be the furthest one away. And they say it in the textbooks all over. If we call this, for example, f at x, and we call this g at x, then this is going to always be, now we've got to always remember there's a 1 plus that. F at x is greater than that, so you're going to always have your f at x here and your g at x here. Okay, because it's further, the f is further away, or to the right, and since it's to the right of that, then we're going to put that first. Here in this example here, we sure will. Okay? Now, alright, there's that. And I hope this has been helpful to you on this regard here. Now, I want to do one more, except this time, I'm going to erase this part right here. Alright, and I'm going to, I think this is red, so we're going to use that. Yeah, my board gets really messy. It's such a small board, but I'm thankful to have it. It's big enough to work on, and I'm thankful that I have it. Oh, integration. Okay, so if you are integrating the limits of integration, we got to figure that out. Well, since we already know that this is 0, 1, and this is 2, 5, this isovierable can move from y equals 1 to y equals 5. You're going to use the y components, not the x. It's not going from 0 to 2. We're not going this way. We're going up and down. Alright, like this. We can only go as far as the graph will allow me to go. Y is equal to 1 and all the way up to 5. So in this case, we are going from 1 to 5. 1 to 5. Okay, like that. Now, there it is. Let's erase this part right here. Maybe you want to see something different than red. So I'm going to erase that, and I'm going to put, well, I'm going to have to erase all of it. And with good reason. Oh my. Okay. red is so hard to erase. I'm going to have to get me some kind of cleaning agent to clean the board instead of just an eraser. Alright, we're going to extend this out. I thought maybe I might extend it out to 4, but I may just go to 3 or something and let that be it, okay? My board's not limitless, I tell you. We could probably just do this about, and so instead of x equals -1, now let's do the same thing except x equals 2. So that means that our line, oh, I had a ruler, is going to be right through here. So let's see. Wow, yeah, that's pretty good. Okay, we're just going to do that. For lack of space, now, I wanted to go out to 4, but you see we're going to have a little bitty, I'm going to have a really crimped space to work with, so we're just going to do 2 right here. It's still going to be a washer because there is open space over here. Alright, now let's extend this thing. Let's use the red one more time, because I don't want to change that color. Let's extend it all the way over. There's a reason for all of my rhymes, I tell you. Alright? Now, how far is this distance right here? We know from here to here. We can look at that and say, well, alright. That distance is 2. 2 units. From here to here, that is 2 units. Okay? I don't know why I did that. Anyway, just me. Alright, now I want us to examine that we have 2 units here. I want this big radius. The big radius is going to be right here, from here to here. That's going to be my big radius. My little radius is this little darker area right here. If I can get my little radius right here, but let's worry about the big radius. How far is it from, let's see, we know this is 2. We are going from 1 to 5. We already know that now. And let's figure out our big R. Okay. That's going to be 2 minus, see now, let's see, what am I subtracting off here? I want to subtract off this right here. Alright, I want to take this away. That's going to be my big R. So if I can get this minus this, I've got it. So this distance is 2. 2 minus. Alright. I already know that the pattern is going to be 2 minus. The whole thing is 2. Okay, got that? 2 minus this, but this is x squared, isn't it? I mean x of 2. But x of 2 is this right here, which is, well, let's see, this, we're going to call this one, we said this one was x of 1. X of 2, let's put it over here. Ooh, x of 2. Alright, x of 2 is equal to y minus 1 divided by 2. We've already established that. So this is 2 right here. I want to take away this so I can have this. Alright? Alright? This is x of 2 right here. Alright, so that is y minus 1 over 2. Taking away the furthest one, see? I'm taking away this so I can have this as my big radius. This is not my hole anymore. Remember, the hole is here. Here is the hole. The hole is over here. But this helps me see everything. Okay, I see everything clearly. I know that this is 2 and I need to subtract off this. If I could just somehow subtract that off right there, I'll have the rest of that. Well, what did I subtract off? I subtract off x of 2. Well, x of 2 is y minus 1. Okay. Now remember, minus sign. Always remember that. Now I'm going to do something else here, and I guarantee you it's going to be 2 minus the square root of y minus 1 squared, like that. So once I figure that out, I'm going to just show it to you. I'm going to prove it that that's true, but I guarantee you that's what it is. Well, let's see if that is. I want this distance here, okay? Well, if I could kind of subtract off the rest of this thing here, up to here, if I know this whole thing is 2, so if I could take away this, so that's touching that purple curve right there, isn't it? Which is, by the way, this. This distance from here to here is x of 1. See that? And that's coming all the way over here. Alright, that's x of 1 as we pointed out earlier. So I want to subtract off the x of 1. So in this case we had 2 minus x of 2. And then in here it's 2 minus x of 1. Like that. Okay, and then of course we squared it, but yeah. Like that. And that's it. So let's write it where we can kind of read it a little better. Pi 1 to 5, 2 minus y minus 1 over 2, okay, minus 2 minus the square root of y minus 1. Alright, close it in dy. Alright. Man, I tell you. Alright. Now, close it in. There we go. That's it. And I guarantee you, ladies and gentlemen, if you can figure this out, you got this. You look at that last video and you look at this video, you've got this. Now you got to do some arithmetic here from here on out, a little bit of calculus, a little bit of integrating. You might want to change this to you might want to change this to the 1/2 here, okay? But you can integrate this, and you can actually put all of this in your calculator and come up with a final answer. You know, when we did it this way, we had a plus sign, didn't we? When we went this way, and we revolved it around the other one, we still went from 1 to 5. But we went 1, oh, I'm sorry. It was 1 plus this one here. Okay, we did this one, didn't we? Alright. Gracious alive. Okay. We did that minus again, still minus because you're taking one, and then it was 1 plus this. Like that, dy. So going this way, you had to add 1 to it. Going on this side of it, you had to take this away. Alright? Alright, that's the way it worked on this one. Okay? Alright, and that's, if you can kind of get these two patterns here, you got this. You understand it. And then you could do anything. And you got to remember, they're not always a washer method. It's not always, and there's also a shell method. But I'm not going to get into the shell method. I could, unless, if I get a request for the shell method, I will do a shell method. I will definitely do a shell method. And it's probably worth the time to do that. To get these, you would have to set these equal to each other to get where the x values are, then plug them in, and you can find the y values very easily. Okay. Some are not that easy though, depending on the function. Okay, if you're trying to compare e to the 2x with sine of x or something like that, and then you might need to use a graphing calculator for that. Okay, and see where they intersect. Okay, something like that. But anyway, all right, that's that. And that's all I'm going to give. The next videos are going to start. I'm going to start putting some problems from as far back as 1997, 1998 to present. I'm going to start putting some of those problems up there and let you look into those. Okay. And then I will move forward. I may put a little BC stuff in here too as well, because there's a little bit of BC. I'm not as familiar with BC, the BC calculus, as I am with the AB. And of course, those of you who are in calculus, calculus is calculus. So, okay. I hope this has helped you. Don't forget to hit that subscribe button, and if you want to. Also, if you want to make a comment, if you can find an easier way to do this, please show me. But again, as I always say, always be correct. We want to be correct. And I want to do things better. I want to be really at my best so I can give you my best. I love doing this. I love calculus and other classes as well. I love math in general. But anyway, this is KP the Math G signing off, and I hope you have a wonderful, wonderful day.